Hello students, I hope you liked my previous video on MongoDB. In that video, you learned the concepts and the basic about the MongoDB with the CRUD operation. In this tutorial, in this video, you are going to learn the aggregation, replication, sharding, etc. In indexing, you will learn how to create index on MongoDB documents. An index in MongoDB is a special data structure that holds the data of few fields of the documents on which the index is created. Indexes improve the speed of search operations in database because instead of searching the whole document, the search is performed on the indexes that holds only few fields. On the other hand, having too many indexes can hamper the performance of insert, update, and delete operations because the additional write and additional data space used by indexes. You will also learn the aggregations. When it's time to gather the matrix from the MongoDB, maybe for some graphical representation or some other operation, there is no better technique than MongoDB aggregations. Aggregation in MongoDB is an operation used to process the data. It returns the computed results. Aggregation basically groups the data from multiple documents and operates in many ways on those grouped data in order to return the combined result. It processes documents and return computed results and can perform a variety of operations on the grouped data, and it would result or return a single result. Using the CRUD's find operation while fetching the data in MongoDB may sometimes become tedious, and that's why we are going to apply the aggregation operations. The third is replication. The replication is the process of synchronizing data across multiple servers. Replication provides redundancy and increased data availability. With the multiple copies of data on different database servers, replication also allows you to recover from the hardware failure and service interruptions. The fourth is sharding. The sharding is the process of storing data records across multiple machines, and it is MongoDB's approach to meeting the demands of data growth. As you know that the horizontal scaling and the vertical scaling. As the size of the data increases, a single machine may not be sufficient to store the data nor provide an acceptable read and write throughput. So in the sharding, you will learn how to provide the shard. Indexes support the efficient execution on queries in MongoDB. Without indexes, MongoDB must perform a collection scan. That is, scan every document in a collection to select those documents that match the query statement. If an appropriate index exists for a query, MongoDB can use the index to limit the number of documents it must inspect. Indexes are special data structures that store a small portion of collection dataset in an easy to traverse form. It is known to everyone what is indexing. Let me tell you about indexing in MongoDB because it stores the value of a specific field or set of fields ordered by value of the field. The ordering of the index entries supports efficient equality matches and range-based query operations. In addition, MongoDB can return sorted results by using the ordering in the index. Let's see in a figure that how exactly the index can be applied. See here, the diagram illustrates a query that selects and orders the matching document using an index. Here you can see that db.users.find. So we are talking of the users collection. We are talking the find, where the query criteria is what the score is less than 30. But the indexing is what the dot sort, that is what the sorting order, that is 1 is for ascending, -1 is for descending. Now score as 1 is the index, that is what they are stored according to the ascending order. So here you can see that indexing. Now if the question is the query criteria is less than 30, so minimum to the 30 all the documents can be selected and that can be shown. Actually the documents are stored according to, they are randomly stored according to the score, or according to they came, the score is 25, then the score is 56, then the score is 45, then the score 75. But now they are stored according to, as the indexing is done, so they are stored in ascending order. So it is like 18, then whatever the first is the 5, and then it is 18, then it is 25, and so on. So the question is score is less than 30, so it is it has to inspect only few documents to result the query, search query. So this is what is the index. So fundamentally, indexes in MongoDB are similar to indexes in other database systems. MongoDB defines indexes at the collection level, and suppose indexes on any field or any subfield of the documents in MongoDB collection. See, it is default underscore ID is the index. MongoDB creates a unique index on the underscore ID field during the creation of the collection. The underscore ID index that prevents clients from inserting two documents with the same value for the underscore ID field. That is what the unique. We cannot drop this index on the underscore ID field. See how to create the index and which are the types of index. Let's see index types. First is the single field. See, to create an index in the in the Mongo shell, we can use db.collection.createIndex. Using the create index, you can have the -1 or you can have the 1. So the first one is the default name for an index is the concatenation of the indexed keys, and each key's direction in the index, either by using 1 or -1, using underscore as a particular separator. Let's see the single field. Because MongoDB provides a number of different index types to support the specific types of data and the queries. For the single field, in addition to the MongoDB defined underscore ID index, that is what the by default, MongoDB also supports the creation of user defined ascending or the descending indexes on a single field of a document. So on a document there are many fields. On a single field you can apply the indexing. So for a single field index and sort operation, the sort order, either it is ascending or it is descending of the index by it does not matter, because the MongoDB can traverse the index in either direction. Okay, at the end or at the starting also you can apply. So here you can see that the score colon 1, that is what the indexing is applied for the ascending order. So whatever the collections, whatever the documents in the collection, all those documents are arranged according to the ascending order, and that is being done on a single field according to the score. Of course, you can work on the multiple field or the compound field, but right now we are talking on a single field, so that is only on the single field or the single attribute we are applying the index, that you can see from the figure. MongoDB also supports user-defined indexes on multiple fields. As this is a single field, you can also have the multiple fields. That is called as the compound indexes. The order of fields listed in a compound index has a significance. For instance, if a compound index consists of the user ID as 1 and score as -1, the index sorts first by user ID, that is according to the ascending, and then within each user ID value it sorts by the score. Look at here, in a particular MongoDB database here, in the set of collections here, they are arranged according to the user ID. So the user ID, let's say they are having their name according to the alphabet. They are stored into the chronological order. So that is AA1, you can see CA2, 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 then NB1, XYZ, and so on. Now into a particular collection, again the data has been, or the collections are sorted according to the score. For compound indexes and the sort operations, the sort order, that is either ascending or descending, of the index keys can determine whether the index can support a sort operation. So here you can see the sort order. For more information on the impact on the index order on results in the compound indexes. If you want to apply the compound index, you can go through the material which is listed below for the sorting order. There are different types of indexes. The third is the multi-key index. The MongoDB uses the multi-key indexes to support the indexing the content stored in the arrays. If you index a field that holds an array value, if you are holding a particular index and which is holding the array value, then the MongoDB creates the separate index entry. It also creates a separate index entry for every element of the array. This multi-key indexes allow queries to select documents that contain arrays by matching on element or elements of the same array. You can see from this particular figure that address.zip as 1. So you are having a particular attribute, or you are having a particular field called as address. Now the zip a zip code is given, and according to the zip code as the ascending order, a particular, because they are stored in the array form. Look at here, address is a field where the square bracket is chosen. So in that particular array you can apply the multi-key index. MongoDB automatically determines whether to create a multi-key index if the indexed field contains an array value. You need not to explicitly specify the multi-key type. So no need to apply the multi-key, or no need to say that this is a multi-key, or this is the compound key, or this is the single field index. Here, by looking at the type of the address, it would identify that this is the multi-key index, because they are the array. So I hope that the indexing is clear to everyone. There are few more indexing also. First one is the geospatial, text indexing, and the hash indexing. I'll just give an overview about the geospatial index, because if you feel that you should go for the geospatial index, go through all the detail into the reference material that I'm going to provide you through the PPTs and a particular study material. See, let's go through the definition of the geospatial index, because to support the efficient queries of geospatial coordinate data, this type of indexing is applied to specific type of data called as geospatial coordinate data. MongoDB provides two spatial indexes, that is 2D indexes that uses the planar geometry when returning results, and 2D sphere indexes that uses the spherical geometry to return the result. So for that you can see the material 2D index internals for the high level introduction to the geospatial indexes, or in your innovative assignment or in your practical. If you are dealing with the geospatial data, you can go through this type of indexing. Next one is the text indexes. The MongoDB provides a text index type that supports the searching for string contents. It also searches for the string contents, and in a particular collection, this text indexes do not store the language specific stop words like the, a, or, n. Like all the stop words, it does not store and stem the words in a collection to only store the root words. So this text indexes would helpful for the text database where it only stores the root words, and it eliminates, or it does not store any of the stop words. It only it applies the stemming, and it applies onto the text into your documents and into your collection, and it only works on, it only store the root words. For that, you can go through all the details of the text indexes in the reference material. The third one is the hash index to support the hash based sharding. See, this is here we'll use the term sharding because MongoDB provides a hashed index type which indexes the hash of the value of a field. Now, in short, it does not directly store the field, but it does apply the hashing onto that, and then it stores the value. These indexes have a more random distribution of values along their range, but only support the equality matches and cannot support the range based, or a range based queries. It does not support the range based, but it supports only the equality matches to a particular field. Replication provides redundancy and it increases the data availability. With multiple copies of data on different database servers, replication provides a level of fault tolerance against the loss of a single database server. Replication provides a particular redundancy or the data availability, because in some cases replication can provide increased read capacity as clients can send read operations to different servers. Maintaining copies or the number of copies of data in different data centers can increase data locality and availability for distributed applications. You can also maintain additional copies for dedicated purpose, such as disaster recovery, reporting, or the backup. So in replication, you are going to learn about how to set the replicas in MongoDB. Replica set in MongoDB is a group of MongoDB processes. A replica set in MongoDB is a group of MongoDB processes. It maintains the same data set. Replica set provide the redundancy and high availability. These are all the basis for all the production deployments. In this particular section, you are going to learn the replication in MongoDB as well as the components and the architecture of the replica set. Here, you will also learn the common task related to the replica set. Look at this figure, the client application driver. What does it write and what does it read? A replica set over here, you know that it is the process, a group of the MongoDB instances which will maintain the same data set. The primary node over here receives all the write operations. You can see that the primary node receives all the write operations. A replica set can have only one primary capable of confirming writes with W as majority. You can see that like a replica set over here, which is replication as a secondary. So that is write with the W as majority with the write concern. Although in some circumstances, another MongoDB instance may transiently believe itself to also be primary. And that can also happen here. The primary records all changes to its data sets in its operation log. That is called as op log. That is operation log. You can also refer the study material for how to set the replica set as a primary. See, the secondaries over here replicate the primaries op log. That is primary receives all the right. So what is the role of the secondary here? The secondary replicate the primary's oplog, that is operation log, and apply the operations to that data set such that the secondary's data set reflect the primary's data set. In short, the secondary, according to the oplog and the database, it would try to retain the copy of the primary. If the primary is unavailable here in this situation, an eligible secondary will hold an election to elect itself the new primary. So from the both of the secondary, again the election will be done and the secondary will become the primary. For here also you can refer the replicas at secondary members, and that you can find out. So in some circumstances, such as you have the primary and a secondary, but the cost constraint prohibit addition or the adding another secondary, you may choose to add a MongoDB instance to a replica set as an arbiter. An arbiter participates in elections but does not hold the data. It does not provide the data redundancy. You can see here in this figure that the in case of the unavailability of the primary, the secondary a node, whichever is eligible, will try to become the primary according to the arbiter. So here, according to this particular arbiter, now the secondary will be electing a particular primary. Here, an arbiter participates in elections but does not hold the data. It does not provide the data redundancy. An arbiter will always be an arbiter, whereas a primary may step down or become the secondary, and a secondary may become the primary during an election. So that is, you need to note down here what is the role of the arbiter and what is the arbiter. Next is asynchronous replication. Secondaries replicate the primaries of log, operation log, and apply the operations to their data sets asynchronously. So here, by having the secondaries data, the data sets reflect the primaries data set, the replica set can continue to function despite of the failures of one or more members. That is nothing but the asynchronous replication. There may be the slow operations, maybe the replication lag and the flow control. And let's see what is automatic failover. When a primary does not communicate with the other members of the set for more than the configured election timeout, that is, I've already told you that is 10 seconds by default. If you want to change it, then you can go into the standard setting and you can change it according to your need. So by default, it is 10 seconds. And even if after the 10 seconds, the primary does not communicate with the other members of of a particular cluster, an eligible secondary calls for an election. That election to nominate itself as a new primary. So here you can see that the replica set cannot process write operations until the election completes successfully. When the primary goes down, then the election would start, and according to the heartbeat, the eligible secondary node would ask for the election, then the new primary would be elected. So here the replica set can continue to serve read queries if such queries are configured to run on secondaries while the primary is on offline, but the write operation cannot be done. These things I've already told. The median time before a cluster elects a new primary, it should not exceed the 12 seconds. Assuming the default replica configuration settings, and you can also tune this time period by modifying the settings. Factor like network latency may extend the time required for the replicas at elections to complete, which in turn affect the amount of the time your cluster may operate without a primary. So without a primary, how your cluster is going to be operate. So even if the factors like network latency may not further delay in your cluster, this would this type of factors are dependent on your particular cluster architecture. Look at the read operation. See, for the read operation, by default the clients read from the primary. However, clients can specify the read preference to send the read operations to the secondaries. In case of the asynchronous replication to the secondaries, it means that the reads from the secondaries may return data that does not reflect the state of the data on the primary. So that you can see here directly with the read preference secondary. In the multi-document transactions that contain the read operations, must use the read preference as a primary. All operations in a given transaction must route through the same member. And for the detail, you can go through the study material for the read operations. Next concept is very much important as far as the big data is concerned, called as the sharding. The sharding is a method for distributing data across the multiple machines. This is suitable for the distributed environments. MongoDB uses sharding to support the deployments with very large dataset and high throughput operations. When you are very much concerned about the velocity, the sharding in the MongoDB is the best option. There are two methods for addressing system growth. For the big data, that is a vertical and a horizontal scaling. You all are aware with the vertical scaling and the horizontal scaling, as I've introduced these two terms in the very first lecture. I'm revising the term vertical and the horizontal scaling. As far as the big data is concerned, the database systems with the large data sets or with the high throughput applications can challenge the capacity of a single server. So when we are talking about the multiple machines or the distributed environment, for example, high query rates can exhaust the CPU capacity of the server. Or working set sizes which are larger than the system's RAM, it would stress the IO capacity of a disk drive. So based on this concept, there may be the two methods for addressing the system growth, that is horizontal scaling and the vertical scaling. Vertical scaling involves increasing the capacity of a single server, like using a more powerful CPU, adding more RAM, or increasing the amount of the storage space. Limitations in available technology may restrict a single machine from being sufficiently powerful for a given workload. That is the concept behind the vertical scaling. Here, cloud-based providers have hard ceilings based on available hardware configurations. As a result, there is a practical maximum for the vertical scaling. There are a lot of softwares which are applicable for a single machine would also be applicable for the vertical scaling machines, because it is a single machine. We are just adding more power to it. And horizontal scaling involves dividing the system dataset and load over multiple servers. That is what the distributed computing is. Adding additional servers to increase capacity as required. Whatever the capacity is required, we are adding those resources. Only this many number of servers or this many number of machines are being added. While the overall speed or the capacity of a single machine may not be high, each machine handles a subset of the overall workload, potentially providing better efficiency than a single high-speed machine. MongoDB sharded cluster consists of the following components. It is basically having three main components. One is called shard, MongoS, and config servers. Shard is what each of the shard contains a subset of the sharded data. Each shard can be deployed as a replica set. Next is MongoS. MongoS acts as the query router, providing an interface between the client applications and the sharded cluster. The third one is the config servers. The config servers store metadata, the data about data, and the configuration settings for the cluster. As of MongoDB 3.4, the config servers must be deployed as a replica set. So you can see that using the graphical representation that the router, the MongoS, and the shard, that is what the replica set available here. MongoDB uses the shard key to distribute the collections document across the shards. The shard key consists of a field or the fields that exist in every document in the target collection. You can choose the shard key when the sharding a particular collection. The choice of the shard key cannot be changed after the sharding. A sharded collection can have only one shard key. To shard a non-empty collection, the collection must have an index that starts with a particular shard key. The choice of the shard key affects the performance, efficiency, and the scalability of a sharded cluster. So you must go through all the details of the shard key. See, there are various advantages of the sharding. First advantage of the sharding is a read and a write. MongoDB distributes the read and write workload across the shards in the sharded cluster. It allowing each shard to process a subset of cluster operations. Both read and the write workloads can be scaled horizontally across the cluster by adding more shards. For the queries that include the shard key or the prefix of a compound shard key, MongoS target the query at a specific shard or the set of shards. These targeted operations are generally more efficient than broadcasting to every shard in the cluster. Second advantage is the storage capacity. The sharding distributes the data across the shards in the cluster, which allow each shard to contain a subset of the total cluster data. As the dataset grows, additional shards increase the storage capacity of the cluster. And hence, it is the pros of having the availability of the sharding. The third one is the availability. A sharded cluster can continue to perform partial read or the write operations even if one or more shards are unavailable. While the subset of the data on the unavailable shards cannot be accessed during the downtime, reads or the writes directed at the available shards can still succeed. So here you can go through all the available material for detailing about the sharding. I've only told you about what is the sharding and what are the advantages and the disadvantages of the sharding. Because the sharding, without sharding, that is called a non-sharded collection and the sharded collection. Or you can have the database which is the mixture of the sharded and the unsharded collection. The sharded collections are partitioned and distributed across the shards in a cluster, and the unsharded collections are stored on the primary shard. Each database has its own primary shard. So that is, they are having few sharding strategies, maybe the hashing, maybe the range sharding, which are the zones in the sharding clusters, or what are the collations in the sharding. how to change the streams. These are not in your syllabus. So if you wish to go into the detail, you can refer the study material for the sharding. I hope you enjoyed learning indexing, replication, and sharding in MongoDB in this lecture. As far as the aggregation in MongoDB is concerned, I will prepare a separate video, or I'll prepare the separate study material on the aggregation with the exercise and the solution for the aggregation. Thank you.